All right, guys, 5. Let's do the warm-up really quick. So use the graph to find the indicated length. Find the length between B and C, or the line segment BC. And guys, that's really easy. All you got to do is count the number of spaces because it's a strictly horizontal line. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8 spaces. So BC equals 8. If you use the distance formula, right, we would find the point which is at B. B is the point -4, -4. C is the point 4, -4, okay? Because we go to the right 4 and down 4 to get to C. And then in order to find the distance between them, this would be x1, y1. This would be x2, y2. We would do the square root of x2, which is 4, minus x1, which is -4, squared, plus y2, which is -4, minus y1, which is -4, squared. And when we do this, we get, this is BC equals, so BC equals the square root. 4 minus -4 is going to be 8 squared, plus -4 minus -4 is going to be -4 plus 4, which is 0 squared. This is just the square root of 64 equals 8. Either way would have been fine, but that's how you get to your answer. Number 2, find the length between D and E. 1, 2, 3, 4 units. D, E equals 4. All right, moving on. This is lesson 4.5, chapter 4, section. Okay, so this section is all about dilations, okay? And I want you to write down a few things that come to your mind when you hear the word dilation. Me personally, I think of the eye doctor. Eye doctor, okay? Because I think of when I get my eyes dilated. Now, when you dilate your eyes, the pupil gets really, really big, right? Or it enlarges, okay? That's all a dilation is. It's either an you're either enlarging an image or you're shrinking it or reducing it, okay? So you're making an image bigger or smaller. Okay, that's why I put the cats with sunglasses on, just to symbolize, that's what I think of when I think of a dilation. They give you those funky sunglasses to wear out of the doctor's office. All right, identifying and performing dilation. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C called the center of dilation, and a scale factor K, which is the ratio of lengths of the corresponding sides of the image and the pre-image. Basically, that really long, complicated definition is just saying we are making shapes bigger and smaller, and I'm going to show you how we do that, okay? There is a method for dilating. All right, so a dilation with a center of dilation C. This is our center of dilation, and a scale factor K. K is going to be the distance between C, P prime, divided by C, P. It's going to map every point P to a figure to a point P prime, so that the following are true, okay? Point P is right here, and then P prime is right here, okay? So if P is at the center C, then P is going to be equal to P prime. So if you are ever dilating about the center, or one of your points is the center, it's just going to be that same point. You're not going to dilate at all. If P is not in the center, then the image of point P prime lies on CP. So notice how if we drew a line from C to P, if we continue that line to CP prime, okay, they're going to lie on the same line. So the image after you dilate is going to lie on the same line. And the scale factor K is a positive number such that K equals CP prime over CP. Okay, and your angle measures are preserved. All right, now one other thing to note, when we dilate, okay, or we perform a dilation, we can tell which line segments are parallel, okay? So PQ is parallel to P prime, Q prime. Okay, we also can see that RQ is parallel to R prime, Q prime. And the last one, PR, is going to be parallel to P prime, R prime. Okay? Now, when our scale factor is greater than 1, this is what we are seeing right now. Okay? That's called an enlargement. So our image, P prime, Q prime, R prime, is going to be bigger than our original shape. So PQR increased in size, right? To get to the red image. When K is in between 0 and 1, the dilation is called a reduction. And in that case, the image is going to shrink, okay? So this is bigger. When it gets bigger, it's an enlargement. And when it's a reduction, we're shrinking. All right, so we're going to do some examples where we're going to find the scale factor of the dilation. And then we're going to tell whether the dilation is a reduction or an enlargement. So let's start by writing down the equation to find a scale factor. So our scale factor K is always going to be equal to C P prime over CP. Now, CP prime is the distance between our point C, which is the center of dilation, and our point P prime. In this case, that's 12. So this is going to be equal to 12 over, and then the distance between C and our original image is P, is going to be 8. 12 over 8. Now, if our image, notice how we started with a smaller image, right? And then we ended up with a larger one. Our K has to be an enlargement, so our K must be greater than 0 or greater than 1, okay? So in this case, 12 over 8, that's bigger than 1, so we're on the right track. Now, 12 over 8 is going to be, you can reduce this. You can divide both the top and the bottom by 4, and you're going to get 3 over 2. And then we're going to write enlargement. Okay? So always simplify your fractions when you're finding the scale factor. K for the next one is going to be, so now we're going to find CP prime, which is 18. Let me write the equation down again. CP prime over CP, which is 18 over 30. This reduces if you divide the top and the bottom by 6. This turns into 3 over 5. Now, 3 over 5 is less than 1. So this is a reduction. So our dilation actually shrunk the image. Here's our original image, right? Our dilation is smaller. Therefore, it's a reduction, okay? Double check that we got those right. We did. And next one. So now sometimes they're going to ask you questions where there's not going to be a graph, okay? So you are going to have to use your knowledge of the scale factor to figure out whether it's a reduction or an enlargement. Okay? So K equals CP prime over CP. In this case, it's 3 over 12, which is 1 over 4 if you reduce it or simplify it. Now, it's less than 1, so it has to be a reduction. And you could tell that as well because if this is our original image length and then it turned into 3, we obviously reduced, right? We went from P being 12 units away from the center of dilation to 3 units away. So it obviously got smaller. Okay, this is a memorized alert, okay? You guys have to memorize this coordinate rule for dilations, okay? You want to highlight it, whatever you want to do, make sure that you remember you got to memorize this. And the coordinate rule for dilations is whatever the scale factor is. So K, you're going to multiply it by both coordinates to get the image. So if our original point was at XY, our image point is going to be K times X, comma, K times Y. All right, so our graph ABC with vertices A at 2, 1, B at 4, 1, and C at 4, negative 1. Let's graph it. Here's our Y coordinate, or Y axis. Here's our X axis. X, Y. A is at 2, 1. So this is 2, up 1. This is A. B is at 4, 1. This is B. And then C is at 4, -1. C. Okay? We connect all these, and that's our original image, okay? Now, we're scaling it by a factor of 2, so K, go ahead and write it at the top, K equals 2, all right? So now A prime is gonna be 2 times 2, comma, 1 times 2. We took the original coordinates, 2, 1, and we multiplied each of them by the scale factor, which was 2, okay? So now A prime is actually 4, 2. Let's plot that. Go over 4 up 2, that's gonna be right here. This is A prime. B prime is gonna be 4 times 2, comma, 1 times 2. So B prime is gonna be 8, 2. So let's move over 8, 6, 7, 8, and then up 2. This will be our B prime. C prime is gonna be 4, -1, okay? So we're gonna take the 4, multiply by 2, and take the -1 and multiply by 2. In this case, C prime is gonna be 8, comma, -2. Move over 8, go down 2, this is C prime. Go ahead and connect all of these points in blue, and we've got an enlarged image or an enlarged dilation of ABC, okay? If you were to draw a line from the origin through A and A prime, it's going to be a straight line, okay? It's a good way to check that you did the dilation correctly, right? Because remember, that was part of our definition of a dilation. All of the image points are going to lie on the same line as the original from the center of origin, or center of dilation, which is the origin in this case. All right. And looks like we did it right. Good job. Okay, let's do another dilation, but in this case, we're using a scale factor of 1/3. So our image is actually going to shrink, okay? Let's plot the points. K is at -3, 6. It's up here. Okay. L is at 0, 6. It's up here. L. M is at 3, 3. And N is at -3, -3. It's down here. N. We connect all of these, makes a nice pretty little quadrilateral. Would you look at that? Looks nice. Okay, now our K for this problem is 1/3. So we're going to take all of these and we're going to divide by 3 or multiply by 1/3. Let's see what it looks like. So I'm going to use red. K prime, capital K prime, okay, is going to be -3, -3 times 1/3, comma, 6 times 1/3. You're multiplying by your scale factor. So K prime is going to be -1, 2. L prime, let's take our original coordinate, which was 0, multiply it by 1/3, and then take 6 and multiply it by 1/3. L prime is going to be 0, 2. M prime, we're going to take 3, multiply by our scale factor of 1/3, take the other 3, multiply by our scale factor of 1/3. We're going to get M prime is 1, 1. N prime. N prime original coordinates were -3, -3. We're going to take each of them, multiply it by 1/3. When we do that, we're going to get N prime is -1, -1. Let's plot these. So we've got 1, 2, 3, 4 new points. -1, 2 is right here. This is going to be K prime. L prime is going to be 0, 2. That's right here, L prime. M prime is going to be 1, 1, M prime. and n prime is going to be -1, -1, n prime. We connect all these, and we've got a smaller but the same shaped quadrilateral. All right, there's our solution, and we got it right. Nice job. Now, I want you guys to think about what would happen if we made our scale factor negative. So if we were to multiply each of the coordinates by a negative number, a negative k, right? I want you to write down what you think initially, and then we're going to take a look at what actually happens. So go ahead and write down what you think. All right, and what happens when you multiply by a negative scale factor, okay? And when that happens, the figure rotates 180 degrees. So when k is greater than 0 and a dilation of a scale factor of -k is the same as the composition of a dilation with a scale factor of k followed by a rotation of 180 degrees about the center of dilation. Wow, that's a lot of words, okay? But basically what it means is if this blue quadrilateral was our pre-image, right? And we multiplied by a scale factor of k, it would turn into the gray one. It would get bigger, right? But if we multiplied or if we had a scale factor of -k, it would completely rotate 180 degrees to the other side of the graph. So if -k would appear all the way down here. And we're going to see an example. It happens on its own. You guys just need to know what to look for, okay? All right, so if we were to graph FGH with vertices F at -4, -2, G at -2, 4, and H at -2, -2, and its image, okay? Let's go ahead and graph it. Let's draw a coordinate plane, y and x, and let's plot these points. So -4, -2, 1, 2, 3, 4, -4, and up or down 2. Right here, that's going to be F. And then we've got G at -2, 4. So 1, 2, 3, 4, all the way up here. This is G. And then we've got H at -2, -2, down here, H. And then we've got, that's it, it's a triangle. Okay, from here we're going to scale it by a factor of -1/2. So remember your coordinate rule, k equals -1/2. So we're going to take that k and we're going to multiply it by each coordinate. So it's going to be F, which is -4 times -1/2. This will be F prime. And then -2 times -1/2. So F prime is going to be +2, +1. H prime is going to be -2 times -1/2, comma, -2 times -1/2. H prime is going to be +1, +1. And I skipped G. So G prime is going to be -2 times -1/2, comma, 4 times -1/2. In this case, this is going to be, G prime is going to be +1, -2. When we plot these, 1, 2, up 1, here's F prime. And then 1, 1 is right here. Oops. Oh yeah. Oops. 1, 1 is going to be right here. And that's G prime. I'm sorry, H prime. And G prime is at 1, -2, so down here. Notice, it's not just a regular enlargement or reduction. Notice how it's completely rotated 180 degrees. So we shrunk our image, right? And then we rotated it 180 degrees. Okay? That's what you need to look for when you scale by a negative factor. All right, looks good. We did it right. And here's your homework. Good luck.